Here's week 10, example 5. In this example, we're being asked to solve the equation 2 times the cosecant of x plus 5 equals 3. And we are interested in solutions that exist only in the interval 0 to 2 pi. Some small notes before we get started here. One, we should notice that in the previous example, example 4, we were looking for a general solution. General solutions are always going to involve that k term, where we're looking for the infinite number of solutions that exist to the equation. Here, we're only interested in the solutions that exist in the interval 0 to 2 pi. So this tells us two things. One, this tells me I'm not looking for an infinite number of solutions. I'm only looking for the solutions that exist within one positive revolution. The other thing this tells me, given that this says 0 to 2 pi, I can tell that we're interested in radians for this problem, not degrees. So let's go ahead and think in radians for this guy here. So the good news is that we're going to primarily use just some algebra concepts to solve here, and then we'll use our unit circle to identify the angles of interest. So 2 cosecant of x plus 5 equals 3. Well, just using some basic algebra steps here, I'm going to first subtract 5 from both sides of the equation. Now I'll go ahead and divide both sides by 2. And finally, I'm going to now think to myself, well, I don't really like cosecant, so I'm going to write cosecant as I know in terms of the sines and cosines that it is associated with. Hopefully we remember that cosecant is the same thing as 1 over sine. And maybe it helps us to think of this as 1 over negative 1 over here. Part of the reason I write it this way is because it helps me to see that my next operation might just be flip both sides of the equal sign here, and this should land us at sine of x equals negative 1. The other way to just think about this is if you're going to do 1 over sine and get negative 1, well, negative 1 is always representing a fraction of the same thing divided by itself here. So I think it's reasonable to realize that if we flip cosecant to get sine, we can flip negative 1 and still get negative 1 because this is negative 1 divided by 1 here. So now we just have to ask ourselves, what angle results in a sine value of negative 1? Alternatively, I think to myself, what angle of rotation within the unit circle has us a height of negative 1? So on our unit circle, I'm trying to picture a height of negative 1. I know that's only going to occur down here. So I'm picturing this as the only angle that results in that most extreme height of negative 1. I know that this is associated with 270 degrees, but immediately as soon as I write that, I'm remembering that we should actually be thinking radians here, and so I'll list this more appropriately as 3 pi halves. I could state my general solution here. I do know that my x values here should be 3 pi halves, plus I know that the cosecant function or the sine function have a period of 2 pi, and so I could give myself a 2 pi k. This would be my general solution, but this isn't really what I'm interested in here. We were given the interval in which we were actually interested in finding a solution here, only the solutions from 0 to 2 pi, and so in this case, this would be representative of the general part of my solution, but that's not what we've been asked to find. Since we're only interested in the ones from 0 to 2 pi, I'm going to really just say, this is the only one I think I'm going to get right there. If I were to add any additional chunks of 2 pi, we would fall outside of 1 full revolution. So my only answer to this equation is 3 pi halves.